Hey, what's up, everybody? Here's the stoichiometry test review. I told you I'd work some of these problems. Let's take a look at this first one. 4 lithiums in an oxygen molecule combine to make 2 lithium oxide solid compounds. All right. If 4 moles of lithium is heated with excess oxygen, okay, if we use a 4 there instead, how many moles of lithium oxide will be produced? Well, 4 is to 2, 4 is to 4 as 2 is to 2. That one was kind of easy, wasn't it? If 20 grams of lithium oxide was produced, how many grams of oxygen were used? Okay, now, if 20 grams of that were made, all right, we need to figure out how many moles that is. So we're going to say 20 divided by, this is 7, 7, and 16. So 14 plus 16 is 30. 20 divided by 30, that's 0.67. So if 20 grams of lithium oxide was produced, how many grams of oxygen gas were used? All right, 0.67 is to 2, as x is to 1. So it's going to be half of 0.67. Let's try this calculator right here. 0.67 divided by 2, 0.335. So we would have 0.335 moles of oxygen gas. We need to figure out how much that weighs. 0.335 times 32. Times 32. 10.7. If you don't know this 32, that's the weight of O2. Okay, let's skip down here. How about we move? Down here? Let's try some of these. How about right here? So we're saying 7 to 10. Already balanced. If I want to react 2 moles of lead 2 nitrate, okay, instead of a 1, I would have a 2 there. How many moles of sodium chloride should I use? X is to 2 as 2 is to 1. 4. Let's skip down here. Let's look at number 9. That one actually has a, tell you what. Let's skip to number 10. That one has a little more math in it. I think the others are easy enough. You probably wouldn't have a issue with them. All right? If we're doing number 10 here. If 25 grams of sodium chloride is used, all right, 25 grams of this, we've got to convert it to moles. Sodium is 23, chlorine is 35.8. 35.4. So this is 58.4. 25 grams divided by 58.4 grams per mole, 0.428. 0.428 moles of sodium chloride would make how many compounds of lead 2 chloride? 0.428 is to 2 as x, this is what we're looking for now, is to 1. 0.428 is to 2 as x is to 1. So we'll take this 0.42 number and we'll divide it in half. And it's 0.214 moles. 0.214 moles. But it said how many compounds. All right, how many compounds are on 1 mole? That's right, 6.02 times 10 to the 23rd. Compounds just means individual little combinations. It's like saying molecules, right? But these aren't molecules. So times 6.02 EE 23. 1.29 times 10 to the 23rd. All right, let's skip around here. Let's try a percent yield problem here. How about this? Do a percent yield problem. 1, 1, 1. That's going to help us out a little bit. If we added 40 grams of calcium carbonate, well, we need to figure out how many moles that is. 40 grams divided by, see, calcium is 40 plus 12 plus 48. That's going to be 100. 40 divided by 100 is 0.4. We don't have to do any math for that. 0.4 moles of calcium carbonate. If we added that and we measured 20 grams of calcium oxide produced, we made 20 grams of that. Determine the percent yield. Well, how much should we make? If we have 0.4 moles of this, we should make 0.4 moles of that, right? So we should make 0.4 of the weight of calcium oxide. Calcium is 40 and 16, that's 56. So we should make 0.4 of 56. We should make, coincidentally, I know this is a familiar looking number, we should make 22.4 grams. But we only made 20 grams. 20 out of the 22.4 we should have made. We had an 89% yield. All right. Let's see. Let's try this last one here. Right here. 21 grams of sodium chloride and 32 grams of lead-2 nitrate are added to the equation. All right, first we're going to balance this. We're going to need a 2 there. It's going to give me a 2 there. I think that's it. 2, 1, 2, 1. 21 grams of sodium chloride. Let's figure out how many moles that is. 21 divided by sodium chloride has a mass of 58.4. So 21, sorry about that, 21 divided by 58.4, almost exactly 36%, 0.36 moles of that. All right, now if we have 0.36 moles of this, and we're trying to make lead-2 chloride, 0.36 is to 2 as 0.18 is to 1. All right? Now let's see if this is going to be the limiting reactant, or we've already done this. Let's try this one. 32 grams of lead-2 nitrate. Okay. 32 grams of PbNO32. We got to add that up. That's going to be 207 plus 14 plus 14 plus 48 plus 48. Now that is because there's two O3s. That's 48 and that's 14. Does that make sense what I did there? So let's add this up. 207 plus 14 plus 14 plus 48 plus 48 equals 331. This should weigh 331. So we had 32 grams out of the 331 grams. 32 divided by 331. Now that's 0.097. 0.097 is to 1 as 0.097 is to 1. This is the one that holds us back. Does that make sense? If we use the lead-2 nitrate, we would end up making less. So this is our limiting reactant. So people, we would expect to make 0.097 moles of lead-2 chloride. How many, which is the limiting reactant? The lead nitrate, lead-2 nitrate is. How many grams of lead-2 chloride would be produced? 0.097 times the mass of lead-2 chloride. That's 207 plus 70.8 because there's 2 chlorines. All right, so here's my 0.097 times parentheses 207 plus 70.8 close parentheses equals 26.9 grams is what you would expect to make. All right, that's it. Let's do this one more. I know this video may be getting long. Let's do an empirical formula problem. How about this one with nicotine? Nicotine is 74% carbon, 8.7% hydrogen, and 17.3% nitrogen, all right? Let's divide each of these percentages. We're going to pretend those are just grams. We're going to pretend we have a 100-gram sample. So we divide them each by their molar mass. This is 12.011. This is 1. This is 14. Let's do 74 divided by 12.011 equals 6.16. So 6.16 for here. 8.7 divided by 1. So 8.7 for here. And 17.3 divided by 14. Okay. 17.3 divided by 14 equals 1.24. 1.24. All right, which is our lowest number? This one is. This is our lowest number. So 1.24 divided by 1.24 would just give us a 1 for N. 8.7 divided by 1.24. So that gives us 8.7 divided by 1.24 gives us 7. So a 7 for hydrogen. And carbon is 6.16. 6.16 divided by 1.24. Gives us almost perfectly 5. So that would be the empirical formula for nicotine, C5H7N1.